Welcome to Mathos Bridge. We train and learn. We shall continue our C++ programming lab session. Let's get started. In today's lab session, we would be experimenting C++ variables using Dev C++. Welcome to our lab. Let me walk through with you a variable.cpp, the sample program, what it does. If you take a look at my main program contains a one variable declaration, which is of type int, integer variable. We know that the value which will be stored in this variable is an int, right? So I have three cout statements. One to display value in the variable, and then second one would be address of the variable, and then dereferencing the address so that I can see the value in it. Indirectly, the line number 9 and then 13 would be the same. Okay, let me compile this program and let me run it. Great. Can you see this now? I declared the variable, but I have not initialized the variable. So the default value that I can see is 0. Some compilers you can see as a 0 as in default value. Some can be a different value altogether. That what we name them as a garbage value. Okay, address of the variable, you see some hexadecimal number. What that means, whenever you declared as a variable, the memory will be allocated for that variable. So let me rephrase. When you are declaring in a variable, the memory gets allocated, and then we will be giving a name to that memory location as a myInt variable. So the address and myInt variable both reference to same position. Think about that way. Okay. So since I don't have any value stored in this variable, so when you are dereferencing the variable, what I am getting is 0, which is same as the line number 1 on the screen. Let me initialize now. See what will happen. I have the variable, right? So what I would be doing, I am going to initialize to value 10. Let me save it, compile and rerun. I should be expecting now 10. Can you see this? On the same memory location, what you will be seeing, the value of the variable is 10. And then if you are dereferencing this address, which also displaying value as a 10. This means myInt variable and then dereferencing address both are actually holding same value. That's a conceptually I was trying to make a point of it. Okay. The another thing is that variable can be updated any times, n number of times, I meant to say. So that means like the system is going to allow you to modify the value of the variable. And you can also create a multiple variables within your program. What that means, I can create a one more integer variable, and I can store the value of the variable to the different value. That's it. If I was try to print them, I can get you a different memory location and then different value as a display. Can you take a look at now? I have two variables declared, and then I was initialized those variables with different values. I was trying to print them, what value that I can see in variable, and then what address is gets allocated for them. And then if you dereferencing, will I be getting same value that what I was initialized previously. Let me compile this. Okay, I have a small errors. the reason is like, I have to put underscore 1 inside, and let me save this and then compile. Typo error. Great. So let me run it. Can you see now? So I have two variables, and then the values assigned to them is like 10 and 100. I can see here on screen. Memory gets allocated for both of them are different. I can also see that. And then value dereferencing those variables should contain the same value that what I'm seeing in line number 13 and 14, which I'm able to see on screen. So what it demonstrated me is that variable means a memory location allocated to it in the system, and you are giving a name to it, and variables can be initialized to any value as long as it accepts the policy of data variable. And then you can create n number of variables as per your program requirement. Variables are allowing us to modify it, so you can modify the variable values, isn't it right? You can see the address of the variable, you can dereference the address to see the content of the variable. This is what you would be seeing from this demo. Let me illustrate a pictorial representation of the variable concept. In our program, you declared a variable, and then what that means, memory gets allocated for that variable. Depend upon the type of the variable, you will be knowing the size of the variable. When you say memory gets allocated, meaning whenever you reference in the memories are associated with the address. This is what you mean to say, address. If you look at the memory location, then this would be the address at which the memory gets allocated for this variable. That is how I am representing. The next stage, you initialized this variable with the value 10. What that means, the value 10 gets loaded into memory location. Isn't it right? And then you also learned that a variable can be modified. Meaning, if I updated this variable with 200, meaning the memory location gets loaded by the value 200, meaning replacing the old value with a new value. Are you clear? Make a point. The address location of the variables remains same in this problem context, but the value will be always a different state based out of the program that you will be doing. Are you clear? This concept remains same across all the programming languages except the data type maybe matters. I'm reiterating a point. A variable is a named data item whose value can change during the course of program execution. You can have multiple variables in your program language.